behind the production of the new Toyota Matrix 2009 microsite Mexico. Discover the process of joining many different disciplines, from artistic to technological, from live to 2 and 3D, from campaign concepts to high-level programming, to bring off tumatrixunico.com online. tumatrixunico.com is an entertainment site where visitors are able to make on-screen fictitious customizations of a new Toyota Matrix 2009 and then print or save them as a build-your-own papercraft car. These not-for-sale customizations can be made combining the near to 200 options in the database. The first step was to take Toyota Matrix campaign concepts and think them web. We are aware of the differences between TV, print, and web communication. In web, you are not just an spectator, you interact. In other words, there is a continuous feedback between the visitor and the media. In graficoide, we take very seriously the analysis, conceptualization, and planning stages due to its importance across the project. We think of this as the basis for successfully accomplishing it. From the beginning, we wanted a hybrid 2D and 3D original art style. 2D cartoonish cars and TV commercials characters were merged with a 3D rendered scenario car and tuning options, all surrounded by a Toyota Matrix lifestyle user interface. A set of 4 cartooned, themed, and animated Toyota Matrices opened the web campaign with a teaser trailer video produced by Graficoide. Meanwhile, the production team continued illustrating and animating the walking cycle and lip sync of the cartoon version of the TV commercials host for the microsite. tumatrixunico.com was quite an artistic challenge because of the many different visual concepts for skinning the Toyota Matrix, screen backgrounds, and iconography needed. Manga-like, tough and flaming, rusty metal, Mexico City's green taxicab, and the mighty Matrix wrestler are some of the original art skins designed for the 3D car paintings and papercraft Matrix printing model. These skins were designed unwrapping and extending the 3D Toyota Matrix model in order to get a 2 dimensions template. There are 196 options for tuning your Toyota Matrix, grouped into colors, skins, stickers, tires, rims, spoilers, accessories, and video wall background categories. Each option was produced both in 2D and 3D and represented with a unique icon. 3D options were rendered for an on-screen display, and their 2D versions were illustrated for printing purposes. More than 150 options were modeled, texturized, illuminated, and rendered with 8 cameras distributed every 45 degrees to get 360 degrees views of the cars and its options, for a total of almost 1,700 images rendered. Ideally, 3D car modeling is done from blueprints. For tumatrixunico.com, car and all options modeling was accomplished only with photo references and sketches. For the initial splash screen displaying the 3 configured cars, the art director wanted a movie poster-like art. A wide-angle 3D camera lens was used to produce the dramatic shots required. Then, extra blue smoke and logos were added and finally, color corrected. The final 3D task was to sketch, model, texture, illuminate, and render the stage. High-resolution texture maps, light testing, and hours of single-image rendering were needed to get the desired visual results for the tuning warehouse. Each time an option is selected and loaded, a smoke curtain is displayed on stage to hide its addition, substitution, or subtraction. This smoke screen is real-color keyed stock footage. The animated host voice was recorded and post-produced at the studio. An original music track was made specially for the microsite. The idea was to compose a piece that reflected the Toyota Matrix 2009 attitude, and it was done. Okay, now it looks and sounds great. But what becomes of a visually engaging site without high-end programming? Tu Matrix Único is composed by a client-side Flash ActionScript front-end and a server-side Python, PHP, and MySQL backend. Our technical area encourages the use of software components to implement the behaviors or functions required by the system because of the benefits they bring, such as task division and easier to update and test applications. Scripts are often treated as distinct from applications since the last ones are usually written in a programming language. Scripts are accessible to the end user, and after being translated into the core language, they enable the behavior of the application to be adapted to the user's needs. Also, this delegation of rule coding to the creative team allows the programmers to fully focus on their next tasks. 2 scripting languages were created. All tuning options cannot be on screen at once. Furthermore, some options need to replace several at once. For example, the all-terrain wheels must replace other wheels as well as the selected rims. These rules were fairly complex to define early in the project. Nevertheless, the flexibility reached with the scripts enabled the project to proceed without delays. All tuning options are displayed in independent layers. Using pre-composed images for each combination was not an option. However, a new issue appeared. The layers should be ordered accordingly to the selected camera. Seeing the car from the front view camera would place the tricycle in a layer on top of the airboat motor. But when rotating the car to the rear view, the layers need to be rearranged. These rules were also handled through a script. One of the main technical issues was the server performance while composing printable images. Each group of options selected by the visitor resulted in the composition of several high-resolution images, usually surrounded by empty pixels. To significantly reduce the server load, our team developed tools for optimizing the huge image database, cropping them to its minimum size, and saving to the database its coordinates within the main canvas. A Python server application is used to compose a papercraft printable image. Composition data received from the Flash application is processed by the server, which queries the database for all needed image paths. Options and coordinates are then merged into one single image, which is returned to the browser for printing or saving. The final stage of every software development project is the testing period, where programming faults or bugs are detected and corrected.